just hold it, please. Tell me why we need confidence intervals in general. We'll get more specific here in a second, but why do we need them in general? Why are they important? What is a confidence interval? What does it do? Think back to yesterday, spinning the penny. That was yesterday, 2 days ago. Spinning the penny. What question were we trying to answer?
It lets you know how close your answer is to the exact.
Okay, so there's two answers, right?
Yeah.
There's the result we got from our sample, and there's the true value that we're trying to estimate out there in the population. So in this class, thank you for phrasing it just like that. In this class, in Math 244, there are only two parameters I want to worry about in this class with you guys. Two, only two. The first one is little p, and the other one is little mu. Haven't even started talking about him yet. I'm thinking maybe at the end of the day we start bringing him in and discussing him and seeing why the hell we care about him. Those are parameters. Those are parameters, right? Parameters, as you remember, they're hands-off. You can't get to them. In general, there are micro examples where you can. I can calculate your class's average on a given quiz because there's only like 25 or 30 of you. That's cheating, in my opinion, statistically, because I can count you all. But in general, you can't get them. But you want to know about them, right? You want to know what's the side effect rate for a medication. Or you want to know, on average, how much weight can we put back on anorexic patients after a certain treatment. You want to know these things in the population, but you can't get the population value. So what do you get instead? You get your sample. Oh, good. You're going to be very specific, Smith. Thank you. For instead of p, we get the sample value p hat. Instead of mu, we'll talk about this now and come back to it. Remember what the corollary is for a sample for mu?
X bar.
X bar. Exactly. X bar from back in the day. Those are your sample statistics. Those are your sample statistics. Assuming you did sampling correctly, and assuming luck is with us and probability is with us, how should these compare to each other?
Close.
Close. And that's where we go, and our stomach turns a little bit, right? Because what does the word close mean? Say that again. Tyler, help me. Say it again. We adjust for closeness by adding on the margin. That's the whole point of both of these. You have to take these bad boys and then add on those margins of error. Because this by itself, how close are you going to be here? When I say close, think mathematically close. Is that going to equal that? Exactly? No. No closeness to speak of. Is that going to equal that? Is this most likely going to be within here?
Yes.
That's why we need confidence intervals. That's why we need confidence intervals, because the true value of what we're looking for is unknown, but we want to be confident that we create an interval that'll capture it. That's the point, right? That's the point of a confidence interval, and that's why we have to use them. It's why you have to have the margin, the plus or minus, on the statistic. The statistic by itself, I'm developing a quiz. It's going to be one of the only mandatory quizzes you guys have to do in here, and you'll know it. I'll mark it on the schedule page, where you have to actually go out and randomly sample, repeat it in Excel, and write down your confidence intervals. Write down your confidence intervals, and see how many of them successfully capture a given parameter that you can't see off the bat. You won't be able. I'll know what it is because I've got it in the back running the show that you're sampling from. So I'm creating a bit of a fictitious environment where I've got a parameter, I've built a distribution, you're sampling from it. And then we're going to see. Sometimes you miss. Sometimes you miss. But at a set level of confidence, that's the percentage of time you don't miss. What's the basic standard for confidence as far as percentages go? 95%. Which means when you make these things over and over and over again, say it again, Tyler, go ahead, say it. No, say it, go ahead, don't hear it in your words.
No, I'm good.
No, I know you're good. Better than good. 95% of the time, what are you going to do? You're going to catch it. I love that phrase. You're going to catch it. This is a range of values. This, thought of algebraically, is p hat minus up to p hat plus. And that's what this quiz that you have in front of you we're going to be doing today is dealing with more of those pluses and minuses. That's a range of numbers that covers a number line. 95% of the time, what you're looking for is going to be in there, assuming you did everything correctly. That means you're gonna miss 5% of the time. So every 20 times, you're gonna miss once. Totally fine. No problem with that. I'll talk about that more and more as we go on. Because it's the difference between finding the first shoe, finding the second shoe, and making a decision based, or finding the first shoe and finding the other 3 shoes in a bag with a tag, and making the right decision. I love how it all ties together. It's so cool. All right. Shall we? Let's get into it. Here we go, here we go. So, oh, this didn't get updated.